Welcome to the first outcome, where we get to grips with 4 words you'll hear again and again: data, information, knowledge, and processing. Get these straight now, and everything else in the unit falls into place much more easily. So, what's the big idea here? Every ICT system exists to take raw facts and turn them into something people can actually use. Think of a fitness tracker. On its own, a stream of heart rate numbers means little, but once it's organized into a chart of your week, it suddenly tells a story. Over this outcome, we'll pin down those 4 terms precisely and see how they connect. Let's start with the first 3 terms. Data is raw and unorganized, just facts and figures with no context, like the number 42 or the initials JW sitting on their own. Information is what you get when you process that data and give it meaning, such as 42 units sold at £19.99. Knowledge goes one step further. It's information you've understood and can act on, like realizing that item is your best seller, so you'd better reorder it. 2 more ideas round out the picture. Processing is simply the work done on data to make it useful, sorting it, calculating with it, classifying or summarizing it. Wisdom sits right at the top, where you use judgment to decide the right thing to do. The thread running through all of this is a simple chain. Data is the raw input, processing transforms it, and out comes information you can understand and apply. Here's a neat way to picture it, called the DIKW Hierarchy, with data, information, knowledge, and wisdom stacked like a pyramid. As you climb, there's less of it, but each layer is worth more, built from the one below by processing. There's a mountain of cheap data at the bottom and just a little hard-won wisdom at the top. It's an old idea, first set out by Ackoff back in 1989. Let's see how those pieces click together. The number 42, sitting alone, tells you nothing at all. Add context through processing, and it becomes 42 units sold at £19.99. And now it's information. Interpret that with a bit of experience, and you reach knowledge. This line is flying off the shelves, and notice the same starting data could tell a different story depending on how you choose to process it. It's worth putting data and information side by side. Data is raw and meaningless on its own. Think of the number 21, a date like the 5th of November, or a postcode fragment like BT7. Information is that same material processed and given context. 21 orders on the 5th of November for the BT7 area. The first is cheap to collect in bulk. The second is what actually helps you answer a question or make a decision. Most systems follow a tidy 4-step cycle. First, input, where raw data is captured, say a till scanning barcodes or someone filling in a form. Then processing, where the computer sorts and totals and summarizes. Next, output, where meaningful information appears like a sales report or a chart. And finally, it's stored and used, feeding into the next decision. Let's ground that in a real example, a supermarket till. A shopper buys 3 items, and the till records the barcodes, the prices, and the time of sale. On their own, those are just numbers. The system looks up the product names, totals the basket, and logs the time, giving you information. A basket of 3 items, £4.45, sold just after 2 in the afternoon in the Belfast store. Multiply that by thousands of baskets, and the manager learns that lunchtime sandwiches sell fast, so more staff go on at midday, and that's knowledge in action. Let's line the 4 terms up with a single running example. The price, $19.99 on its own, is just data. multiply by the quantity, and add VAT, and that's processing. The result? An order total of £47.98, including VAT, is information, and deciding to offer free delivery over £45 to nudge orders higher, that's knowledge putting the information to work. It's worth pausing on why processing is the star of the show. It's the bridge that turns meaningless data into useful information, and without it, the data just sits there, sorting, searching, calculating, summarizing, formatting. Those are the everyday operations. And here's the clever part. The same data, processed differently, serves different people. A set of exam marks can become a class average for the teacher or a simple pass list for a student. Now for a crucial point, information is only as good as the data behind it. There's a well-worn phrase in computing, garbage in, garbage out, or GIGO. Even the fastest, most expensive computer will churn out nonsense if you feed it flawed data. The specification names 4 things that decide quality: accuracy, age, level of detail, and completeness. Let's meet those 4 factors. Accuracy asks whether the information is correct and free from error. Age, or currency, asks whether it's up to date. Level of detail asks whether there's enough to be useful without drowning you. And completeness asks whether anything important is missing. Good information usually has to satisfy all 4 at once. Take the first 2 more closely. Accuracy is about correctness, and a single mistyped price, say 99 pence entered as £99, makes the whole thing unreliable. Age is about currency. An out-of-date address or last year's prices can be worse than having nothing at all, because you'll act on it and get it wrong. The other 2 are just as important. Level of detail is a balancing act. You need enough to do the job, but not so much that the key point gets buried. Completeness means all the pieces you need are actually there. A customer record missing its postcode or a form with no phone number leaves you stuck at the worst moment. Here's what happens when each factor slips. Poor accuracy leads to wrong decisions, so a price typed as £199 blocks every sale. Out-of-date information sends you down the wrong path, like a sat-nav routing a driver onto a road that closed months ago. Too little detail, such as sales are up with no figures, can't guide a budget, and a delivery address with no postcode simply can't be delivered. Let's see poor quality bite. A charity sends an appeal to 10,000 supporters from a mailing list last touched 3 years ago. Because it's out of date, many have moved and the letters bounce back. Because some names were mistyped at sign-up, others get the wrong greeting. And because over 1,000 records have no email, the cheaper email route isn't even an option. The result is wasted postage and a weaker response, poor information quality with a very real price tag. Detail deserves its own example. A manager asks 2 staff for a report on last month's website performance. One comes back with the website did well, far too vague to act on. The other hands over 60 pages of raw server logs, far too much to read before lunch. The good report sits in the middle. Visits up 12%, the top page named, and one clear recommendation to act on. So how do you keep quality high? Validate data as it's entered, checking a postcode is in the right format, for example, to protect accuracy. Update records regularly and stamp them with a last updated date to manage age. Summarize and format your output so the detail suits the reader. And use required fields and cross-checks so nothing's left incomplete. The honest takeaway is that quality isn't one thing. Information is only good when it's accurate, current, detailed enough and complete for the job in hand. Let's draw this together. Data is raw facts. Processing turns it into information. And once you understand and apply that information, it becomes knowledge. The DIKW hierarchy shows value rising as you climb from data towards wisdom. Processing means all those everyday operations: sorting, calculating, classifying, summarizing, and formatting. And the worth of what comes out depends on accuracy, age, detail, and completeness, because garbage in really does mean garbage out. That brings us to the end of the first outcome, where we've built the vocabulary the whole unit rests on: data, information, knowledge, processing, and what makes information trustworthy. If you'd like to go deeper, the reading list points you to Rowley's paper on the wisdom hierarchy and Ackoff's original article, both of which explore the DIKW idea properly. There are approachable overviews from the British Computer Society and BBC Bite Size, and 2 lovely case studies from the Office for National Statistics and NHS Digital showing raw data becoming published information. Have a browse, then move on when you're ready.